To Mrs. O'Graham's Maths, we are going to take a look at a vectors question. I've had a request to do some of the more straightforward vector questions and show you how to get started on those for anybody that's struggling with the first steps of getting into a vector question. So just take a pause and have a read through this one. I much prefer to deal with vectors when they're in column vectors. That's why I've rewritten out the information in the question rather than them being in IJKs. I just find them easier to think about. So we want to show that the line passing through A and B does not intersect L. So first of all, we need to find out what the line through A and B is, get an equation for that. So we start by having the, we need to work out what the direction of A to B is going to be. We just do a little recap of how we get that if you are struggling with these ones. If we want to go from A to B, we can't just get that direction vector yet. We don't have that information, but we do know how we can do that by going through the origin. So first of all, we go from A to O, so we're going backwards of the vector that we've got over here of OA, and then forwards on the OB vector. That is, do OB and then negative of OA, put them together, and we will end up with this vector of A to B. So then if we put the numbers into that, vector of AB. So the line through AB can be written as a starting point, so we'll just use A, we could have used B as well, and then go in the direction of the vector AB. Now I'm not going to use mu. Mu is used for the equation for L, so we'll use lambda in this one, and it'll be lambda lots of the direction in which we're headed. So this gives us a start point in which to head a certain multiple in that direction. Okay, so then if we want to show that these two lines don't intersect, we do that by attempting to find the point of intersection and showing that it can't be possible. Values of lambda and mu that would make this true, so that the two equations were equal to each other, and we'd be able to come out with one point of intersection and the coordinate of where they intersect. So if we go ahead and try and solve that, we are hoping that this comes out to something that is quite obviously not possible. We've got each line of the equation here that we'll set as equal to each other and attempt to solve for lambda and mu. The top two lines, and then whatever value we get for lambda and mu to make these two true, we'll put it into the third line and show that it's not possible. So I'm doing simultaneous equations. We've got two equations in two unknowns. So I will start by adding together those two lines to giving me the answer for mu being 2. So then from there we can work out lambda back into equation number 1. So if mu is 2, this comes to 0. This would also have to be equal to 0, so lambda would have to be minus 1. Then we check it against the third line of this bit here. So check the third line, we would get 1 plus 2 lambda equals minus 1 plus mu. But if lambda is minus 1 and mu is 2, then we end up with, we've got side 1 on the right, which is clearly not equal. So there is no solution, no point of intersection. Part 2 now. And for this one, we are going to look at, we've got the line L, and we've got the point A, and we want to work out the distance from A to the line L at 90 degrees and show that it's 1 over root 2. Helps when they give you the answer, and then you'll know whether you've got it right or not at the end. Okay, so I'm going to label the point where that perpendicular hits the line as being N. Now there is a video that takes you through slowly how to do this question. If you're not sure of what I'm about to go on to, it might be a good idea to go and have a look at that video first. Right, so if we think about this point N as being somewhere on the line, it's somewhere on L, so it's going to take this form here, and we can put it together with a particular value of mu. So we're going to have 2 minus mu, minus 2 plus 2 mu, minus 1 plus mu, as representing this position N where mu is some particular value that gives us that coordinate of ON. Carrying on with that, we can work out AN if we can get AN, then we can find its length and work out the distance from A to the line. So AN is ON minus OA. So ON we just worked out up there. So if we then take away A, which was 1, 1, 1, we will get 1 minus mu minus 3 plus 2 mu and minus 2 plus mu. Okay, so now we have AN in terms of mu. There's one other bit of information we haven't used yet, which is that these cross at right angles. So if two vectors cross at a right angle, their scalar product will be 0. And the direction of L do their scalar product, and that should come to 0. So we will have 1 plus, oh no, it's times by minus 1, so minus 1 plus mu. Then we have minus 6. I'm just going to take a pause so you don't have to watch me go through all that. Scalar product to 0, and then working through, we get that mu is equal to 3 over 2. So when mu is equal to 3 over 2, we can put that back into AN. So now we get AN is equal to 0 minus half, just by putting mu into this. So now we can get our final thing of what we were looking for, the length of A to N, which will be to do the square root of half squared, 0 squared, minus half squared. Quarter makes a half, so we've got the square root of a half, which of course is 1 over root 2, just as we were asked for. Alright, hopefully that helped you out on getting started on these vector questions. If you liked that video, help others out by hitting that like and subscribe down there, and they'll be able to find it too.